This
Hey
call is
everyone.
now being recorded.
Hey everyone. Welcome to the final presentation for O1JS performance profiling by Mike. So Mike, over to you.
Thank you. So thank you for this opportunity to learn more about the Mina project. It was a lot of learning and it was very interesting. And I'd like to present some of the things that we learned. So basically, I should actually give a background, but what we have so far and what I want to present is a tool for testing multiple versions of Mina, or the O1JS foundational library, against each other in a form of a battle royale, where you can see which functions which version performed better on. And I've developed automations for running these tests, collecting them, and then I'm working on a primitive GUI for displaying them in a serverless fashion. And it's a GitHub app, so you can log in with GitHub. And I've also done this on my mobile phone, on my Samsung, and I had to learn a lot about Node.js and TypeScript. I tried to do everything in TypeScript, so I kind of was challenging myself. So yeah, so what we have so far is we're able to run these tests in GitHub Actions against in GitHub Actions and locally against the matrix of versions. So I've done two different takes on this automation. The first version that I did was using Docker and Docker Compose, and that was a little bit more complicated. And then I redid that to be as simple and with as minimal changes to O1JS as possible, and stripped out the clinic reports. And I'm just doing a raw data report. So we're going to have to do some more work to merge these different threads together. But okay, we're collecting heap and CPU performance data. We're pushing those results to GitHub artifacts. And then I worked on different ways to report on that data collected. I also pushed it to Hugging Face at one point. So we have different versions. And then we were working on an experimental prototype of a serverless reporting front end that uses GitHub as storage. So part of the project was actually getting set up for mobile development and getting that all to work. I finally got this Kiwi browser with Firefox, and I also ran on VNC, virtual network computer, and I'm also using Visual Studio Server. So I can tell you guys all about the steps that I did to work on Mina now mobile, which I think is a plus because I'm reducing the entry point. So you could actually work on Mina using your Chromebook, for example. So this is reducing the cost of entry. And we're also working on the GitHub Action, or the GitHub app, which lets you access the GitHub data and the artifacts. So basically, the artifacts are stored in GitHub. I can show you that real quick. Use zk CloudWorker tests, and here we have a matrix of jobs that are being built, one for each different branch. So I can show you, we have results coming in from all different versions. And if you go back here, where is it? Here. This is the source code. No, that's not it. Okay, that's not part of the presentation. Let's get back to the presentation. But we're collecting, there's the GitHub actions are collecting the results. Let's just go back to that one page real quick. So when we produce these results, they're stored on GitHub as a zip file, and then you can download that, but you have to be logged in. And it's produced a lot of data. Each run is producing 40 megabytes or more. So you can't just you can't just view this in the browser. So that's why I have to create a front end for actually displaying that data. Now we did some examples of that. I'll show you some screenshots. We'll just stick to the slides. And then we worked on some. I'd worked on some different experiments on the GUI side, trying to make it useful, and also have some plans for better reporting. So these are some of the issues. The code base is very complex. You have OCaml and Rust that are being compiled to WASM, and that's integrated into TypeScript. And that's using, well, I've been using React. I think actually the Next.js is also using React. And then you have the whole knowledge of zero knowledge proofs and elliptic curves is all being tied into here. So it was a lot of learning and a lot of incompatible versions. It was a real nightmare. It seemed like I spent a lot of time just getting everything to work and fixing all the incompatibilities and getting my environment set up. So that will also burn some time on this.
I'm sorry, could you share what those incompatibilities were?
Oh, they weren't related to O1JS. They were just in TypeScript. If I wanted to get, let's say, the chart library to work, then it didn't work with this other library. And
Gotcha.
yeah, and every single version of everything didn't want to work with every other version. It was just a nightmare in getting everything to be compatible. And I can show you some of the bugs that I opened, some tickets that I opened on the way. So TypeScript development is a lot of the time you're spending and then trying to, if it runs locally, trying to then deploy it to Vercel opens up more problems, and something that worked locally wouldn't work on the server. And then you have to debug that. Yeah.
Gotcha. Thank you.
Okay. So here's the big report from that showdown that I shared previously. And this is filtering the functions just with the name Rayon in them, which is related to the thread system, I think, in the Rust. And these are the ones that are basically, these are like some of the main functions, and you can see the different branches of the code and where the most time was spent. So you can see that these branches here are actually spending a lot more time in the same functions as the other branches. So we're comparing the same functionality between different versions of O1JS, and that's a key takeaway where we can then drill in and find out why it's slower. And I shared some of these results here as a Google Sheet. You can just open that up real quick. This is a simple pivot table. I had to fight with it to get it to work, and this is why I'm working on the reporting tool.
So is Rayon like a function call, or is it like a library?
I'll show that to you. I'll show that to you.
Okay.
This was a filtered. We'll get to that. This is a class of functions that match that name. I have another sheet I can show you where we pull that together. Let me see if we can see it here. Here, you see here on the left, this stack. This is a report from Clinic.js for my first attempt, and you can see Rayon iterator. So these are like the workers that they're calling the proof engine. So this is part of the WASM proof engine. There's basically the Rayon. If you just look for the term Rayon, you'll find all the functions that are going to basically be contributing to the main code in the system, which is multiply 3, and then this fields, these field operations, where they're multiplying the elliptic curve fields together, which basically most of the time is spent in elliptic curve operations. Okay, let's start with that. And I should give you a better overview of the functionality. So let me see if I have a table of those. I guess it's not very clear from my presentation. But so if we look at this stack, you can see it very clearly. So it starts with the Kimchi verifier, batch verify at the bottom, right? And here's Plonk accumulate. So these are like the functions, and then they call other functions going up to the top. And at the very top, you have these field operations and the multiplications on the big fields. And these are the wire stress. This is the wire stress algorithm, I think, in the arc elliptic curve module from Rust. Okay. So this shows you basically, this is going to show you how the multiplications are being called and how they're being tied into the main system. And we can filter out individual functions and then compare them. So I just picked out one group of functions and compared them. And I can show you some more results leading up to that, how that happened. Yeah, let's go. That's just more of that same detail. Okay, here's another view of the data, which is using the bubble profiler, and this shows you how send transaction and create transactions are calling each other. It seems to be in like some kind of recursion. So these are some examples of different visualizations that you can get. Here, this one I thought was interesting. This shows you the timeline of time spent on the finite field, arc FF fields, which is basically the elliptic curves. And it shows you the time spent in the multiplications, and you see that there's gaps in between them. And you also see that there's slowdowns here. So it's not completely maxed out in terms of its execution time. So any gaps that we see here, if we get rid of those gaps, it should speed up the entire process. Okay. So this is kind of like the start of analysis of where we're looking for opportunities. Here.
Sorry, I have a very quick question.
Yes.
Based on this graph, I kind of wanted to touch upon how this data was collected. Was it by running like the O1JS test suite against each branch, or was it a very specific test case we are looking at right now? Or is it an aggregation of all of these together?
Okay. So I have different data sources. One is the O1JS test suite, and I have a pull request for that. I have two different branches of O1JS test suites. My first attempt, which was a kind of a mess, and the second attempt, which was an attempt at cleaning it all up. And then I also implemented the zk Cloud Worker test suite from Michael, which gives you a real good end-to-end test of the application. So I used that to drive the testing of 30 different versions against each other, but we can also test them, and I have tested them individually and collected data individually of the test suites as well. So we have a whole bunch of different data sources.
Gotcha. Thank you. I have like one quick question. I don't want us to get hung up on it.
Go ahead.
The gaps you see in this particular graph, do we know if this was waiting for some other process to finish, or are we sure like this thread of execution had, is halted for
I'm
some,
not sure. I'm not sure
yeah.
yet. I don't have any
Okay.
conclusions on that particular one.
Okay.
And in this system, these graphs open up more questions than they give you answers,
Hmm.
which is why we need to put them in the hands of everybody.
Hmm.
Everybody needs to use these, and everyone needs to be looking at them, and then we can make bounties for improvements on things that we identify.
Gotcha. Gotcha.
That's what
Thank
my
you.
plan is. So I want to put this in the hands of people, and then they can say, "Hey guys, look at this," and I'll show you an example when we get further. But this is just, I thought this was interesting, and I like this graph because really, if your slowest operation is multiplication, right? Then you want to see those multiplications with no pauses. We have to be constantly multiplying, right? To get through all the multiplications needed, and there should be no breaks in the multiplication. It should be flat
Hmm.
out 100% multiplication all the time until we get to the end. So any pauses, right, or any dips, or any narrowing should be seen as a problem. It's
Hmm.
either the data is not in cache at the right cache, it's at a different location, it has to fetch it from disk, it has to fetch it from a page that's not loaded, something is not in the cache line. You know, there's some kind of pipeline error that causes these gaps,
Hmm.
right? And if we get rid of all the gaps, then the system will be faster.
Cool. Gotcha. Thank you. I mean, there's just one more question from Michael is the graph for O1JS 1.9? But I think you may have answered this tangentially by saying it's from multiple sources.
Yeah. Well, this report here is from a whole bunch of different versions. Here I can show. I was going to show that to you. Hold on. GitHub workflows. Let's see here. So here's the set of tests that I ran here. So it's this branch with this commit hash, right? So here's the different branches on the right. 018, 19. So this one is here, 19. And then we should be able to see that in the graph as well. So this slow one here, I guess 8D8. Yeah, there's. Anyway, it's not easy to tell from this graph at this point. I can find, we can figure it out. The data is in there. It's just not easy to see it right now. I'm still working on the reporting. It's not this is not all completely automated and done to the fact that it's going to produce all these graphs yet. This one was produced manually with a whole bunch of different Excel sheets from the data, and then I'm working on replacing that here as we go. This is the one that I want to show you that from my work with Michael, when he asked me to look into performance issue on the 1.9 that we worked on together. Do you remember that? Where
Yep.
so I have on the left and the right, I have the old version and the new version, and where they had the performance issue. And here you could see that the CPU usage dropped, and there was that huge stall in the beginning. And that's not existing here. So we were able to see very quickly that there was a problem. This is using the clinic doctor report. And also, if you look here on the left-hand side, there's still some blocks with event delays here. And you see that the CPU usage spikes are between these event delays. So there's definitely room for improvement in the code base.
Awesome. Thank you. Yeah.
Yes? Let's go to the next slide. Okay, we did this slide too many times. We did that one. Okay, here's another view of a flame graph. This is from the constraint system. This is using the Firefox profiler. So the data we collected, you can plug into different web apps. Here's the Firefox profiler. So you can just use this GUI here and view the data. But it's still not easy to to aggregate all this data. So we need better tools for pulling in multiple versions. Like this is what I'm working on. But here in this graph, we can see that it's actually spending some time producing source maps and stack traces and stacks in O1JS. So here, witness. So it's doing the constraint system, and the constraint system is producing a stack trace, and that stack trace is now taking a bunch of time, right? So here's an obvious one we can optimize for, because we can pre-compile the stack traces, I think, and we don't need to do a stack trace for every single, we don't need 400 stack traces, I'm pretty sure. They're all going to look very similar. I'd be surprised if this is actually needed. But that's something that we can see here in these reports. Okay?
Yeah, so I guess it's a way to combine multiple graphs to identify a bottleneck. Would be
Yes.
a way to use the tool.
Yes. And that's what I'm working towards. This is an example of the profiler running on my phone, in the browser on my phone, just as an example that you can actually live profile your data directly in the browser on your phone, which is nice. Okay, now you get to see the horrible types. This is like my first TypeScript app, okay? So don't laugh at me too much. But this is a GitHub app. It's running locally. I have it on Vercel, but I was still running into problems on Vercel, but I can show you it is there. This is the older version, but it's working as a GitHub app, and it's querying the data from GitHub. I still have to update this. It was getting some build problems, but let's go back to the slides. So this gives you a list. You feed it a list of repository owners, and it'll list out all the top 10 or 100 or whatever recent branches, recent repos. So first you pick a repo. Then it loads the repo from GitHub. It shows you here the repository description, number of stars, updates. It even gets the README. So we can basically use this to browse our GitHub repos and organize them, and then pull in the performance data from them. So we could have like all of the different zkApps in this dashboard and pull them in, right? That's kind of my idea. So we can have a holistic view of all of the Mina ecosystem. And then from there, you can get a list of the runs. And this is basically using the GitHub API. So if we go to actions, that's that list of runs here, okay? So I have that here in this list of runs. And then when you select a run, you get a list of artifacts. You can select an artifact that gives you all the data from it. This is basically one of the outputs of the thing. And then you can unzip it. So this lets you download and unzip the files into your local server. And then you can query the results from the local server and then produce an aggregate sum here. This is just an example of a sum from the two things that I downloaded. But the amount of work that I had to do to get this to work was crazy. And then from here, in the future, now that's what I have so far, and then I can show you some of the stuff I was planning on doing with this data. Here is an example of a query builder. So I want to pull this data into some kind of SQL type system, and you can build interactive queries here in Node.js. Oh, this is something I worked on where dynamic dynamic list box that you can drop down, and you can define enums and produce drop downs for selecting between queries. So I spent some time learning TypeScript and getting that working. And here's an example I was working on for the tabular report with changes. And this is a REPL that I was working on, so you can type in commands, and basically you'll have your own little dashboard where you can type commands in. And that was working. And then here's some example graphs that I started with. But I wasn't able to integrate these graphs with the backend rendering, and it was getting all types of JavaScript errors. So I wasn't able to get this for the final presentation. I'm very sorry. But I'm going to continue working on this until I have something that's actually viewable. Now, this is a pivot table that I found, React Pivot Table JS, where you have all types of nice features. You can do drag and drop type analysis, and that's where I'm trying to go with the drill down. So we're going to pull the data into these pivot tables, let you write some SQL queries basically, and then do reports and interactive analysis. That's where I want to go. Yeah, so here we are. I would like to continue on this for some time. For next 2 months, I would say I can work on the interactive reporting, pivot tables and graphs, and get wider adoption of these tools in the community, try and get this stuff merged and approved. And those are my next steps that I'd like to work on. And that's what I have so far, guys. And I have a whole bunch of code and repos that I worked on. I have the patches and pull requests for O1JS and for the zk worker. And I was able to help resolve one issue at least, and find that one, help them pinpoint that one bug in the 1.9. And I think that there's more work to be done. So that's my presentation so far. And thank you very much for this chance to learn more about Mina. I'm sorry that I didn't get as much done as I wanted to, but I think we're going in the right direction.
Yeah, thanks a lot. I mean, the tool looks really awesome, and there's like a lot of scope from what you said for it to be created as a dashboard where maybe even these zkApp developers don't need to set up the GitHub Actions, and this tool would pull it for them, if I understood correctly.
Absolutely. Absolutely. Yeah. It's set up right now. Where if we merge this into O1, if we merge these pull requests, let's say the O1JS pull request, let's see. If we merge the O1JS pull request into this GitHub action, then it'll be collected for every pull request. Every time someone wants to send in a change, we can then show the performance results and compare it to the baseline and say, hey, oh, we noticed an issue. Let's see. But also the zk Cloud Worker tests can be used to test lots of different versions. But yes, let's go to let's go to O1JS. Let's see, is it this one? Recording last month. Yeah, this might be it. Yeah, I already squashed this down into one change. So this is doing some small changes to add the recordings here. And then it's putting them into, the artifacts and uploading them. So it's not a lot of changes to these GitHub Actions to get the data collected.
Gotcha. Thank you. And sorry, I had a follow-up question. If someone wanted to run this performance graphs on their project, what would be the best way to go about it? Should we ask them to get in touch with you, or do you have a guide that someone can use?
We're going to make a guide, and we're going to make some documentation. That was part of the project to make it usable. But basically, it would be to collect the data. So, and then that data, when the GUI is working, when the GUI works, you'll just click on it and you'll click on your branch. I can show you. Right now, let's see. Close this. Go here. So right now, these are the different branches of my repo, but eventually it'll show you your branches and your changes. And then you want to do a report, you click on here, and then you can see the different runs, and then you can collect. Basically, already here, I want to, even on this level, I'd like to have a little graph and show for each run, did it get better or worse, right? So this is going to be super easy to use for the end user where they don't have to do anything at all. As long as the data is collected, as long as they collected the data in their GitHub Actions, we can pull it out. So if you go, I'll just show GitHub Actions. Here. So these are these megabyte files here, right? As long as these files are being collected in the GitHub, you can just download them. You can even just do it manually, right? You can just download it, you can open it up, and then you can take that file and plop it into an existing profile. You can go to profiler.firefox.com, for example, and I can load the profile from a file that I've already downloaded. No, that one's not going to work.
But I think we understand the flow.
Yeah.
I also wanted to take if there were any questions from Carol or Michael. Please feel free.
For me, the question is, it would be good to use not only for proving. I understand that proving takes a lot of time, but it would be good also to use for building transactions, because it takes right now something like maybe 5 seconds. And the part of it is because I guess that some like long functions like analyze methods are called. And also, you need to fetch some data from the node, and it's also a problem because sometimes you cannot fetch it immediately, and you need to like retrieve and all that stuff. So basically, when it's going to just building transaction without proving it, it also something like a few seconds, maybe 5 seconds, or and it's a lot of different processes that I try to make them in parallel as possible. You cannot put in parallel everything because without fetching, you cannot basically continue to build, so there are some limitations. But it would be good to make it faster, because basically going from 5 seconds to 2 seconds, it's good for user experience.
So you're saying that the end user, the creation of transactions in the end user is currently taking 5 seconds, and that affects the user's perceived performance.
Yes. It's much better. If you go, for example, to Lumina, it now takes maybe 30 seconds, 1 minute, because they prove it also. So this proving, you already described everything, but also it would be helpful for just building the transaction.
Yes, I understand.
Because the idea is very simple. As soon as you build it, you can present it for signature in our wallet. So it's basically the time between the user press the button that he wants to make the transaction.
Yes.
And between the our wallet showing to our wallet is very fast, so it's not delay on that side. The delay usually is on building transaction. So it would be interesting to have. Usually building transaction is like one function, like maybe 2 screens, something like this. It's not very big, but it's important from the point of view of user experience. So it would be good to have exact workflow for those kind of stuff.
And that could be captured in the O1JS, and the unit test should capture some of that, I think.
Yes, and it's not only usually with O1JS, because basically also there is some stuff with fetching the data from the databases that are not related to O1JS, or from the Minascan node or whatever. So it's not fully O1JS. It's broader scope.
Yes. Well, you're saying that it could also be just loading the data, getting the data into the system, and where is it coming from, and where are the bottlenecks?
Yes. So basically, by manual approach, I was able to decrease it. But what I'm doing, basically, I take all the long processes instead of calling await, I just call them to get the promise. And then I call await on this promise only at the time when I cannot wait anymore, when I basically stuck, I need this data. So I do
it's like lazy loading.
Lazy loading, exactly. So the question is for every developer would be very helpful to really understand where this lazy loading should be added additionally, because
we need to create
we
a
do it
timing
theoretically,
diagram.
but practically we don't have quite good tool to understand exactly. And in case, for example, lazy loading will give you 10 milliseconds, it doesn't make sense to do because, for example, the main is O1JS side.
That's right.
And also with O1JS,
the total usage and threads and swapping. I found, for example, the system is spending a lot of time waiting for results, right?
Mm-hmm.
But what if you knew how long to wait? What if you didn't stop every 5 milliseconds and say, "Hey, are you done?" But you said, well, this process I expect to take 30 milliseconds, so I'm not going to poll it so quickly. If we did adaptive polling.
Yeah, so also it's a problem with rate limits, because basically I need to slow down polling, because as soon as I poll too frequently, I have rate limit on Minascan nodes.
Yeah, that as well.
It's a problem, yes. So you basically, I put specific delays in many of my scripts for the reason that if I do not do it, I just hit the rate limit for.
Let's just stop right there and say we don't want any polling. We want to be pushed. We want the Mina to push us the important changes. And we don't want
it would be very good to do, and basically theoretically GraphQL supports it, but I don't think it's realistic.
No, not ready, but in general, we don't want it polling at all. For big data sets, you don't want to poll.
Yes, I actually in some of my project I use nuts to do such stuff. So it's amazingly fast, and I just basically wait for nuts to come, but I don't think
that. How do you spell that?
Nuts. Yes, let me. Nuts. It's amazing. Very little. To use this technology. Yes.
I'll look into that.
Yes. So it's possibility, but it's not. I don't believe that Mina will add this technology. So it's just wishful thinking. But what is important is to have some easy to use tool.
We can create a custom node.
To look at building speed and possibilities for lazy loading, because it's exactly what people will see. And Lumina is a good example. So you can go to zkApp Discord to look at what people are saying about the performance when they need to wait for transactions. And this absolutely clear application for what you did. So, for example,
and I wanted to say yesterday on Twitter, someone wrote that the transaction speeds on Mina are very bad. They wrote.
Okay, you cannot do proving in 5 seconds usually.
No.
Yes, but it's a problem how you organize it, how you present it. Basically, it's a question of presentation now.
Yes. Okay, so the other question I was thinking, if we created a custom node that would push the data. So you create a normal Mina node that processes the transactions, but it caches the data in such a way that it pushes it to you in a way that you can use it.
You can look at Rust node. The new Rust node is very good. It's stable. I
Yeah.
was testing it for a few days. It was working quite good. It's required right now approximately 5 gigabytes of memory in my Docker, and it's more or less stable. As soon as after 24 hours, it's always consume 5 gigabytes, so it's quite stable on memory consumption.
Oh, that's good.
I did not test it for a week, but it was quite stable. And basically, I do believe that it's possible to edit. And now they're working on GraphQL. You can go to Rust node questions.
Yeah, this
and
is open
the most
node.
recent
Yes, the
is
Rust node.
about GraphQL. Yes, so basically, probably you can, if you have any idea on it, you can speak with the team. It's inside Mina Foundation.
Yes.
Because it's internal project of Mina Foundation, and maybe they will be open to consider such opportunities, because their next stuff that they will build is web node based on this Rust node. I understand that can be used in web applications. So basically,
I tried that web node, or the open Mina running in WASM in the browser, and it took forever to load the graph. It was just loading and loading and loading.
No, it was just built for the previous DevNet.
Yeah.
On the previous DevNet, it was quite fast, but then this DevNet was stopped, and it cannot connect anymore because blockchain is not there. So it's not problem of open Mina. It's problem that blockchain is not there anymore.
Oh, okay.
And they didn't change for the new blockchain, as far as I understand, because they concentrated on the Rust. But it used to work very fast. And it used to work on mobile, it used to work on web. Just it was with Berkeley, the previous test network.
Okay.
Yeah, Carol has added a link. I'm going to stop the recording, but I'm going to leave the meeting open. So if you guys want to carry on, please do. I need to